product. With OS, if I develop one embedded product, so performance wise, if you see, multitasking wise, if you see, so the embedded product which is having OS can perform well. Embedded product which is having the OS can perform a multitasking. And we are trying to understand the why Linux operating system. One of the main reason of the Linux OS is a free source code. And second is it can be ported into different hardware architecture. And third is large community support, so that if you have any problem, you can, like this, few security reasons are also there, but we are not entered into the detail of all these things because at this stage you can't understand it. After that, we started thinking about the components of an operating system. So can you tell me how many components of an operating system? There are two major components of operating system. There we can say there are two major services of major parts of an operating system. One is called applications and another one is called as the services. User user is going to use the user is going to use the applications. Applications need a services. All the services combinedly we can call as all the services combinedly we can call as a kernel, core of an operating system. Some of the services automatically starts when your operating system is started. Some of the services are automatically available when your operating system when you installed it, and some of the services you need to install externally whenever you required it. And these services are capable of communicating with the resources. What is the meaning of resource with respect to operating system environment? With respect to OS environment, what is the meaning of the resource? Resource is nothing but a hardware. Resource manager means they'll managing all these hardwares. After that, we started thinking about one more point, that is a booting steps of a Linux OS. Booting steps of a Linux OS. That what is the meaning of booting steps means whenever you switch on the system till the login screen comes, what is the background work is taking place. At this stage, anyway, we can't understand in the in-depth level. In a simple way, I'm trying to explain you because this is the starting portion. So the first step of the booting process is, what is the first step of the booting process is a BIOS, a basic input output system BIOS. Now can anybody tell me where is this BIOS is present? Can anybody tell me where is this BIOS is present? In the ROM chip. The manufacturers of your motherboard or your CPU, I can say. So what they will do, they'll burn one program into this ROM. That program is called as a BIOS program. So can we say when you give a power supply to your system, the first program starts executing. The first program starts executing is a BIOS program. What is the job of this program? Very simple. The job of this program is it is a separate chip. Yes, correct. It is a separate chip. In your motherboard, you will observe a separate portion, separate chip. So the main purpose of this BIOS program is the main aim of this BIOS program is the basic input output peripherals are connected properly or not. Basic input output peripherals means checking the basic hardware connections, basic integrity check. That normally it is called as an integrity check. It will check the basic hardwares are connected properly or not. I told you example, RAM is connected properly or not, it will check. I told you one example, hard disk is connected properly or not, it will check. Like this, the basic peripherals which required, it will check it out. Now my very simple question is, suppose you have the webcam, external webcam to your laptop. If you don't connect external webcam, your operating system is going to be loaded or not, your operating system starts working or not. Again, basic webcam is not a what you called mandatory device, right? Mandatory things. Hard disk is a mandatory, RAM is a mandatory, yes or no? Processor is a mandatory. It is not an essential, it is not a mandatory, it is not a compulsion. So even though your webcam is not connected, not inserted properly, not properly placed, then also the operating systems. So that's what I means to say you that in this step, the basic input output peripherals are connected properly or not, it will check. Yesterday, one of the student raised one question, how it will work, how this will check. That is not a simple process to understand. There is a internally handshaking methods will be there. Internal processors, they have their own way of communication. Like hardware, they have their own way of communication. There is a separate procedure to check the device is properly connected or not, properly able to communicate it or not. Like that we can. I don't know, you may know it or not. There are some companies which are still working on this bias. There are few companies which are working on the bias platform. Have you heard one of the company called AMI, Chennai based company, AMI, American Megatrends? So this is working on the, some of them, our students, my students are working in the bias level. So the basic input output peripherals are connected properly or not. Who will check the basic bias program? What is the second job of the bias? Can you tell me? What is the second job of the bias? The second job of the BIOS, it need to decide which is the bootable device. Most of you might have observed, you can change the priority of the bootable device. You can, in a BIOS settings, you can change it. Like, so operating system should be booted from pen drive, or should be booted from hard disk, or should be booted from network. Like this, some options are there, you need to select that option. And like you may know that in a simple way, I'll tell you, so pen drive enable disabling also you can do, passwords also you can put it in this bias basic program. This is like a very simple, very basic GUI will be there. It is not an advanced GUI means, GUI means GUI means, will you agree this is a graphical user interface? BIOS settings also just GUI will be there, not that much advanced GUI, very basic GUI will be there. So this is the job of the BIOS program. So BIOS, in this BIOS settings, in this BIOS settings, which is the first bootable device you selected? Which is the first bootable device you selected? Suppose your first bootable device you selected as a pen drive. First bootable device you selected as a pen drive. So what the BIOS will do? It will start searching the pen drive. That's what. Of second step is a second step is a MBR. What is that MBR? Observe. MBR is nothing but the full form of MBR is master boot record. Observe. Performs some system integrity checks, search and loads and executes the bootloader. During this BIOS setup, change the booting sequence. Booting sequence you can change it. Booting sequence means first which device it should search, second which device it should search, third which device it should search. You can change it from where the OS is there. Now, second step is the second step is MBR. MBR stands for master boot record. The full form of MBR is master boot record. Now, what is this master boot record? Very simple. It is located in the first sector of the bootable device. Again, so BIOS will give the control to this is the BIOS. This will give the control to MBR. What is this MBR? MBR is nothing but master boot record. record. MBR is nothing but master boot record. Where this MBR is present? This MBR is present in the first sector of the bootable device. First, instead of sector, we can say the first part, the starting part of the bootable device. What may be the bootable device? Will you agree? Your hard disk may be, normally your hard disk is a bootable device. Otherwise, yesterday I told you, you can make your pen drive as a bootable device. You can make your pen drive as a bootable device. So BIOS, what it will do, it will give the control to MBR. MBR is present in the first sector of the bootable device. This MBR is less than 512 bytes in size. Observe this MBR record, master boot record. Record means some information. Will you agree? Record means some data, some information. In your college days, you might have maintained so many records. Yes, sir? Some information. So here also, the starting sector of the bootable device, the starting portion of the bootable device, this MBR will be there. Suppose it is a pen drive, or suppose it is a hard disk. So in that, the starting portion, one small information will be there, which is less than, can you tell me which is less than 512 bytes? One of your friend is asking, MBR is also present in the ROM. Can anybody tell me MBR is present in the ROM chip or not? MBR is present in the RAM or not? Answer is no. MBR is present in the starting sector of the bootable device. Suppose your bootable device is a pen drive. So in a pen drive, or suppose your bootable device is a hard disk. In a hard disk, this MBR will be there. I hope S13 you got it. It is a starting sector of the bootable device. Now MBR starts, when MBR starts, so can I say BIOS is giving the control to MBR? Will you agree? The BIOS is giving the control to MBR, master boot record. Now this MBR is less than 512 bytes. It contains the information about the grub. This MBR contains the information of grub. Grub is nothing but a grand unified boot loader. This MBR contains where the loader is there. Now can you tell me, in the command prompt, you may know that in the command prompt, when I write /a.out, who is responsible for loading this executable file into the RAM? Again, you tell me, when I write on the command prompt, when I write /a.out enter button, who is responsible for loading this a.out from hard disk to the RAM? Loader. Similarly, there should be some responsible person who need to load your OS from hard disk to RAM. Again, similarly, there should be some responsible person who need to load your OS to the your OS to the RAM. Yes or no? How our program is loaded into the RAM. Similarly, operating system is also one program. There should be somebody need to load your program into the RAM. Now that is called as a loader. That is called as a loader. So that loader information, where that loader information is there, this is the BIOS and this is the MBR. This MBR contains that loader information, where the loader is there. I used one term called GRUB, grub, Grand Unified Bootloader. One more thing I need to tell you, every operating system is having its own loader. Again, every operating system designers, they'll also design one loader. Again, every operating system designers, they will also design one loader. If you take Windows, can anybody knows what is a Windows loader name? Can anybody knows a Windows loader name? If you take a Windows, if you take a Linux loader name is Lilo. Lilo. Linux loader name is a Lilo. Yes, Windows loader name is NT loader. Windows loader name is NT loader. Linux loader name is Lilo. Lilo. Similarly, every operating system they have their own loaders. But if you think about this grub loader, grand unified bootloader, the speciality of this loader is it can load Windows OS also, it can load Linux also, OS also. So it is capable of loading multiple operating systems. So where this loader information is there, in the starting sector of your bootable device, that is MBR. See, S16, there is no separate meaning for the loader. There is no separate meaning for the loader. The name itself tells you loader. It will load something. S16 loader. Yes, it is a general. It is a loading something from one particular place to another particular place. In this, in this, in this, operating system is present in the hard disk. From hard disk, there should be somebody responsible to loading into the RAM. That is called as a loader in this particular point of view. According to this particular discussion, what we are doing it. Got the point? So, what is a loader? This is a universal loader, grand unified boot loader, but every operating system is having its own separate loaders. Instead of using these separate loaders, we can use a grub loader, grand unified bootloader. This loader information, where it is present, that information is present in the starting sector of your bootable device. Got the point? Starting sector of your bootable device. So observe, in a simple way we can say, so in a simple terms, MBR, in a simple terms we can say MBR loads and executes the grub bootloader. So first bias given the control to MBR, MBR is going to give the control to bias given the control to MBR, MBR is going to give the control to MBR is going to give the control to bootloader. Getting the point? Till now OS is not loaded. You need to consider till now OS is not loaded from hard disk to the RAM. Till now OS is not loaded from hard disk to the RAM. Is this is clear? MBR work is clear? It is working like a chain. Yes, it is working as a you may know that thing called compilation stages, step by step. Like here also, step by step works takes place. How many steps are there in the booting process? How many steps are there? Yesterday I told you there are 6 steps are there. Will you agree? In this entire booting process, there are 6 steps are there. Now we are talking about a second step. The second step is very less size, 512 bytes, which is responsible for in this grub information, loader information will be there. BIOS is separate and bootloader is separate. BIOS is present in the ROM chip, bootloader is present in your bootable device. S25. So MBR job is done. Now the control goes to Now the control goes to the grub. Now the control goes to the grub. One of your friend is asking H1, but these are present in a different parts. How it goes groom one to another one. So that's what, to understand that you should know so many things about the low level things, kernel level you need to know. But this is not the correct time to discuss. And once the operating system, once what you call real time operating systems started, Pramod sir will show you the files also where it is present and all other things. Is it clear what I'm saying? How internally they linked, at this stage you can't. If you think that, you can't move further also. If you start thinking that how internally they linked, you can't move further also at this moment, I am saying. Once the real time RTOS and other things are going on, you will get some more clarity on these things. Grub is one type of loader, correct? A18, correct? Grand Unified Boot Loader. Like Windows loader name is NT loader, like what you called Linux loader name is a Lilo loader. Similarly, this is the one separate loader. The speciality of this loader is it can load any operating system. So let's think about what is the grub will do. Grub stands for Grand Unified Bootloader. Observe, if you have multiple kernel images installed on your system, you can choose which one need to be executed. Observe, what is the job of this grub is, this grub will display on the screen. If suppose you have the multiple kernels, suppose you might have installed the Ubuntu separately, you might have installed the Windows separately. Dual partitioning you might have done. Getting the point? Suppose in your laptop you might have done the dual partitioning. You might have done the dual partitioning. So Windows you installed separately and Linux you installed separately. Then who is responsible for displaying which one you want? You want to load in Linux OS or you want to load a Windows OS? Which one is responsible for displaying that? Answer is a grub loader. And in a Linux also, you may have the multiple kernel versions. Yesterday I opened the kernel.org. I displayed the what is the latest kernel. Yesterday I opened the linux.org and I shown you what is the latest kernel. Suppose in your laptop you have the Ubuntu. In a Ubuntu you have the different kernels. You might have loaded, your images are there in your hard disk. So the grub responsibility is to display what are the kernel images are there, what are the different operating systems are there in your hard disk. You installed it, and it will wait for user choice. It will wait for user choice. Observe the third point. Grub displays a splash screen, waits for few seconds. If you don't enter anything, it loads the default kernel image as specified in the grub configuration file. There is some configuration files will be there. Again, grub displays a screen and wait for few seconds. If you don't enter anything, it loads the default kernel image as specified in the grub configuration file. Kernel image means the OS. What is the kernel? Can I say kernel is a part of the heart of the operating system? A18, core of an operating system. Now that it is started, that it will load. You may have the different like you can install the different kernels. You can put different kernels. It will wait for 30 seconds. Yes, some of that time also you can change later. So if I type uname -a, observe in this, because I'm using this as a subsystem, this kernel version is 4.4.0. In a Windows, I am using this as a subsystem. What the Windows people did is, because almost most of the persons, most of the people are now started working on the Linux, they also started introducing the Linux. Getting the point? As a subsystem here. In this lockdown period, what I did is, why should I take a risk of installing the Linux, and if something installation process gets wrong, I may get an entire, I may lose entire data. So that's why I'm taking this as a subsystem. Getting the point? So what happens normally generally is, suppose you might have installed Windows separately, and you might have installed Linux separately, huh? Dual booting. In a Linux also, you might have installed some 4.4 kernel version, 4.5 kernel version, multiple images may be there, multiple kernels you might have installed. Multiple images means multiple kernels you might have installed. So what this grub will do is, it will display, you have the Windows 10 or Windows 8 or Windows 7, whatever it is. You have the Linux. In the Linux, what are the kernel versions are there? It will display a menu. Correct. It will display a menu. And it will wait for user's choice. Depends upon the user's choice, it will load that kernel, that OS into the RAM. If you don't select any, if you don't select any, selected any choice, by default, whatever it is there in the configuration file, that kernel is going to be loaded. Got the point? Voice problem? Are you getting the voice problem? The problem is, you may know that I connected to, I am in office. In office, Airtel is not working, Act is not working. Both are having the problem. So I connected my, what you called, mobile. Just a minute, I'll see. Okay, so I hope you got what is the job of the grub. Grand Unified Bootloader. And it will display multiple yes. And step number 4. Now we are talking about Linux booting steps. Will you agree? We are talking about a Linux booting steps, Linux operating system booting steps. So suppose we selected the Linux kernel. So can I say Linux kernel from hard disk? It is loaded into the RAM. One thing I need to ask you, very basic thing. When I type /a.out enter button, suppose, try to imagine till now whatever we written. When I write /a.out enter button, all of you know what is the meaning of a dot. Will you agree? Dot is nothing but a present working directory. And what happens when you type /a.out? Will you agree? Your a.out file which is present in the hard disk, it is loaded into the RAM. Hmm? Now my question is, when this a.out file is loaded into the RAM, is it the meaning that this a.out is deleted here and pasted here? One image is pasted. When I say one copy is pasted, will you agree? One copy is pasted. Here also the same thing. Now whatever this is, after OS is loaded, we are talking. Once the OS is loaded, we written our program, we compiled our program, and we started our executable file into the RAM. But what the grub will do, grub will load operating system into the, it is called as an image, correct? Grub will load operating system into the image into the RAM. Now I should not use with respect to Linux, I should not use a operating system, I need to use a kernel. What is the meaning of a kernel? Can I say all the main managers, all the important managers are loaded into the RAM, like process manager, like file manager, like memory manager, like thread manager, combination of all services. Yes, combination of all services are loaded. Now observe, what is the kernel? After loading all the services, what it will do is it will mount to the root file system. Have you heard some terms called FAT16? Have you heard FAT32? Have you heard NTFS? Have you heard EXT2? These are the file systems. Yes, in a pen drive, when you're what you formatting the pen drive, it will ask FAT16, FAT32, whatever it is. Now it will mount the file system, root file system. Now one thing, if the root file system is not mounted, you can't access the hard disk. You means user can't access the hard disk. So mounting means very simple, connecting. Now tell me, when you connect a pen drive, non-technical word is it is connected properly. Technical word is mounted successfully. A8. Got the point? Non-technically we will say connected. Technically it is called as a mounted. So once it is gets mounted, then only you can access the pen drive. Similarly, the root file system will be there, like NTFS, ext2, ext3. One more speciality of the Linux I need to tell you. Linux can understand all other file systems. Linux operating system can understand all other file systems. And I should not enter into in detail about what is the file system, what are the different file systems are there, and all other things. So in a simple way, I can say once the kernel is loaded, so file system gets mounted. So later user can use the files. Got the point? Once the file system gets mounted, then only later user can use the files. Now, will you agree? I am opening this. Observe, I am opening that folder. I am able to see these files. Able to see desktop and all other things. How it is possible when the file system is not gets mounted at this step? I can't see the file. I can't connect. I can't get the data from the hard disk. I hope you got this in a simple way. So what the kernel will do, once all the managers are loaded into the RAM, so once the managers are loaded into the RAM, it will start the file system. Every operating system is having its own file system. File system will give the meaning to the file. File system is nothing but a protocol. File system is nothing but a rules and regulation. Like our India is having separate rules and regulations. Our India is having our own constituents, whatever constitution. Similarly, operating system is also having in a hard disk how the data is going to, what is the mechanism, how the data is going to be fetched, what is the, there are so many things are there. I should not use the terms like what you called inode table, file informations, what are the types of files, what are the block sizes. There are so many informations. All those informations are present in a file system. If file system is not gets mounted, so we can't access the files. There is no meaning for the files. This is device driver related things only. Yes, I can say this is device driver related things. So I hope you got this point in a simple way at this level, at this stage. And after that, kernel executes the one program called init program. I told you, I told you yesterday, the RAM is divided into, can I say RAM is divided into two spaces. One is a kernel space and another one is the user space. Will you agree? This is the RAM. Now tell me, who is responsible for loading all the managers? Who is responsible for loading all the managers into the RAM? Who is responsible for loading all the managers into the RAM? Answer is loader. All managers combinedly called as a kernel. Who is responsible for loading the kernel image into the RAM? Answer is loader. Kernel is nothing but all these managers. One of your friend asked one question. So S16 is asking one question. My question is, for Android file manager is there, like was for every, see, for every operating system there is a file manager will be there, which is responsible for managing this file, managing the hard disk. All managers combinedly called as a kernel instead of using a separate terms. So instead of using a separate terms, we are using a kernel. I hope S16 you got an answer. So who is responsible for loading the kernel? Who is responsible for loading the kernel? Loader is responsible for loading the kernel. In this, once all the managers are started ready, all the managers are ready. All the managers are ready. So first step, what happens? File system gets mounted. Once the file system gets mounted, later user can use the hard disk. Later user can use the hard disk, put the data, get the data. And after the file system gets mounted, next thing what happens is one of the programs starts executing in the user space. One of the programs starts executing in the user space. What is that program called? What is that process called? Init. INIT. What is that process called? Init process. One thing I need to tell you, this is one of the program. When you switch on the system to switch off the system, it will continuously starts running. This is one of the program. This is one of the program. When you switch on the system to switch off the system, continuously it will run. One of your friend is saying that, sir, I observed this type of term sbin slash init in ATM machine when it is not working. Yes. I don't know. Nowadays, some of the ATM machines they are converting into Linux only. The problem is previously you might have observed Windows ATMs, Windows operating system. But what happens is because of that support and all other things, upgradation and all other things, all the things are shifting into Linux environment now. Getting the point what I'm saying? Suddenly, Windows people, I don't know, you may know it or not, they stop supporting some Windows 8 something. They ask the user to update Windows 7 also. So imagine I developed one machine in that I using the Windows 7. If suddenly the company told that we are stopping that support, so definitely we need to upgrade it. For that again some license, again so much if other things will be there. There are so many issues are there. Anyway, those issues are also Windows people now they are trying to solve it. Flexibility is there, but one of your friend is asking who is responsible to give error if there is a problem with the file system. File manager is responsible. This manager is responsible for what? This manager is responsible for what? Managing the files. Listen, again I'm saying there are so many questions may be there in your mind. All the file related activities will be managed by the file manager. All the process related activities done by the process manager. All the what you called network related activities are done by the network manager. Yes. Init is one of the process which is present in the user space. Init is one of the process which is present in the user space. This is one of the program starts executing. This is one of the program starts executing when you switch on the system to switch off the system. This is a daemon process. You can say one of the student written daemon process. When you switch on the system to switch off the system, it will continuously run. Now all other processes, small processes are under the control of init. Is this is clear? Is this point is clear? Kernel loads the init program. In a simple terms, we can say OS is loaded into the RAM. In the step number 4, what we can say in a simple way, OS is loaded into the RAM. I hope you understood the step number 4. Let's move to the step number 5, init. Since it was the first program to be executed by the Linux kernel, so it has the process ID as 1. Again, it was the first program to be started executing by the Linux kernel. So it has the process ID of 1. What is the PID, process ID, and all other things? Anyway, we need to discuss it. So this is the first program under the control of Linux OS. It starts running. So this is the process ID is 1. What is sbin? This is one directory, G5. G5, try to understand. This is one directory, sbin /bin/bin/sbin. In that sbin, there is one program will be there, init rd. I think we can, I don't know, we can see it or not. vi ls/sbin. In this, there is one init. Getting the point? I should not discuss the kernel level issues at this stage because, as all of you know, we are not going to discuss the kernel programming. We are going to discuss the system programming. But you should know the basic idea about that. That is the reason I am discussing in a simple way. You should know the basic idea about that. No voice? Voice is not coming? Is the voice is coming or not? So I am trying to explain you in a very simple layman can understand, but in the later stages, little bit high-end terms I'm going to use it. But if I use the high-end terms at this stage, again, you'll feel very difficult. I hope it is clear. So now tell me, under the control of Linux operating system, which is the first program starts executing? Under the control of Linux operating system, which is the first program starts executing? Can I say that is the init? And one more thing I need to tell you in a simple way, the programs, OS is also one program. You may get a doubt, sir, OS is also one program, right? This is also executing, right? Will you agree? OS is also a set of programs. Please try to reply it. OS is also a set of programs. Can I say those are also started executing? Can I say those are also started executing? But the programs which are executing in the kernel, those are called as a services. Again, the programs which are started executing in the kernel, those are called as a services. And the programs which are executing in the user space, those are called as a processes. Again, The programs which are executing in a user space is called as an applications, or we can call as a processes. Every application is one process. Every application is one process. What is the process? What is the multiprocessing? Anyway, we need to discuss it. In it, there is no particular meaning. In it is the first. In it. In it is the first program initiated by the kernel. This is one of the program under the control of these managers started running in the user space. And some of the processes they'll under the control of init only. So will you agree? In a step number 4, in a simple way, we can say OS is loaded into the RAM. And init, since init is the first program to be executed by the Linux kernel, so it has the process ID as 1. So what the init will do? Observe what the init will do. Init identifies the default init level from some configuration information will be there, /etc/init tab, and users, and uses that to load all appropriate programs. Some of the small services started running, and I should not say the processes which are running in the user space are all processes only, but there are small services also started running at this stage. Who will start those services? Who will start those services? Who will start those services? Init. Now tell me, one thing I need to, in a simple way, I need to tell you. I am using the pen tab. Will you agree? I am writing this, whatever I am writing here, whatever I am drawing here, I am not using the mouse. I am using the pen tab. Will you agree? The pen tab driver will be there. Huh? Observe here. In a simple way, I'll try to tell you. Just a minute. So in this, you might have, if you see here, I can't annotate it. All of you are observing this graphic tablet, a graphic tablet. So these are the small services. These are the small services which started running by the init. All major services are already started, right? When the loader is loaded, all the important services are already loaded, like file manager, like process manager, like network manager. These are already loaded. Important managers are already loaded. All the small services started loading by the this init program. Small drivers or small services started loading by the init program. I hope you got this. And don't worry about that etc init tab and all others. There is one folder will be there. In that etc init tab, the file will be there. Which are the things you need to execute? It will be present in that. And after that, and it will start after loading all the small services. The last step is run level programs. Here also the basic programs are started running. When the Linux system is booting up, you might see various services getting started. Observe. When the Linux system is booting up, you might have seen the various services started running. Example, you might have seen starting the sending mail. Okay, like this. If it is not a GUI, if it is a command based, you might have observed so many things on the screen. All these small programs are started. All these small programs are small things are started running in this run level. You can say, in a simple terms, we can say small services that executed in this step and decides the Linux run level. What is that run level? Try to understand. There are different run levels are there. Example, available run levels are there. 0 means halt. 1 means single user mode. Single user mode. Only one user. 2 means multi-user mode without network file system. 3 is a full multi-user mode. Unused. Like this, different file systems are there. Different run levels are there. Now I don't know the command works are not here. If you're those who are using direct Ubuntu, you can use it. There is one command called run level. Now it is showing unknown. But from your side, those who are using direct Ubuntu, you can check it out. So in which mode your OS should work? Do you know that some of the in a what you called in a Ubuntu, you can make it as only command mode also. There is no GUI mode. Some of the companies, they will work only N5, correct? Some of the one of the student is N5, means different things. Mine is N5. That's what. Different run levels will be there. So network enabled, network disabled, and multi-user, single user environment. In which user environment it should work, that is decided by here. After this everything is done, then what happens? Login screen will come. After these works are done, so what happens is login screen comes. Once the login screen comes, just we need to provide a login ID password and we need to start using the services. So if you summarize this discussion, if is this discussion just for making you to just basic information, advance anyway in a later you will get it. Each and every step you will get it later, not in my lecture, promotional lectures you will get it. So first step is what? BIOS. Second step is what? Second step is what? MBR, master boot record. Third step is what? Grub. Fourth step is what? Kernel. Fifth step is what? Init. Sixth step is what? Run level. What is the BIOS job? Try to, in a simple and a fast, try to let's recollect it. BIOS job is, don't reply anything, I'll tell you. The BIOS job is to check the basic input output peripherals are connected properly or not. BIOS job is to check the what you called bootable priority, the like bootable device is a pen drive or hard disk or whatever it is, and give the control to that device. So if my bootable device is a hard disk, so in a hard disk starting sector, some portion of the sector, one information will be there, that is called as an MBR, which is a 512. This information, this holds the information of the loader, which is going to be loaded OS into the kernel. So there are different loaders will be there. Every operating system is having its own loader, but grub is nothing but grand unified bootloader. The specialty of this grub is it can load any operating system. And what the grub will do, it will display the multiple operating systems if you have in your system, multiple kernels if you have in a kernel images if you have in your system, it will display that. And wait for user choice, depends upon the user choice, the grub will load the kernel. Loading the kernel is nothing but all the important managers are started running in this level in the kernel space. And what the kernel will do, kernel will mount the file system so that later user can use the hard disk. And after that, kernel will start one process that is called as the init process in the user space. This is one of the program which is going to execute under the control of the operating system. And init will start this run level. This run level means init process ID is one, correct? The run level means in this stage, last stage, what happens is your system should work in which level, that is like single user mode, multi-user mode, and what you called network enabled, network disabled, like this different. And not only that, small services started running in this run level. If every work is done fine, everything is done fine, then login screen comes. You need to provide a login ID password. Once you provide a login ID password, so then you started using the OS by taking the help of applications. Will you agree? Everything is an application here. Whatever I am using here, I try to observe the cursor, mouse, everything is an application. These applications internally communicates with the services. Like if I take an example of this, what you call Chrome, internally network manager. Can you say this internally communicates with file manager like this? So every OS is having the same booting steps, means first three is same up to the grub, depends upon this. But as all of you know that we are talking about, Linux operating system booting steps. So Linux operating system booting steps. So I should not go for more on this run level. I should not go for more on this run level. There are the different run levels are there. Like in our lab, what happens is when you switch on the system, it will directly connect it to the router. Sorry, it will directly connect it to the server. So different run levels are there. So I am not going to discuss in detail of this. What is the use of this? What is the use of this? What is the use of this? So if you want detail, you can further, but you can't understand it this moment. After everything is done smoothly, then what happens? Everything is done smoothly, then login screen shows up. These are the six. So one of the student video is on. Please switch off it. These are the six different steps in the booting process. Once everything is fine, once restart, yeah, reboot is also one of. I think if you reboot, as one command is there where you can directly reboot it. Everything is done, login ID password. So then you need to provide it, and you can use the applications. User uses the applications need a services are capable of communicating with the respected resources. That's what about the that's all about this booting steps for the time being. Next discussion is very important discussion, that's I mentioned here, process and process management. You need to understand what is the process. You need to understand what is a multiprocessing and all other things. Observe here. Agenda is what is a process, what is a multiprocessing, how many types, what is a process management. Observe this agenda. What is a process? What is a multiprocessing? How many types of multiprocessings? What is a process management? Foreground and background processes in a terminal. Basic commands in a process management. Memory layout of the process, and what is the shell. S16 is asking one question. Sir, show run level. Restart is one run level. My question is regarding the booting settings. What is the keys F1, F12? See, when you type F1 or F12, that BIOS settings will come. That is different, and this is different. BIOS settings will come. That is not the booting settings, I think. BIOS settings it will come. Okay. What is a process? First, you need to understand what is a process. Very simple meaning of the process is a process is a program in execution. Again, a process is a program in execution. Now tell me, till now, from the day one onwards of the Hello World program, what we did using the VI editor, we written one program using the GCC compiler. We created one executable file. What is the name of the executable file here? If I write -op1, what is the name of the executable file? Will you agree executable file is p1? Now tell me where the p1 is created. Tell me where the p1 executable file is created. Can I say it is created in a hard disk? Huh? Now, to see the output, what we commonly will do? To see the output, what we'll do? To see the output of this program, we'll write /p1. Now, all of you know that when I write /p1, this executable file is loaded into the RAM. So now what we need to say is, when this executable file is loaded into the RAM, suppose this is a P1 executable file, when it is loaded into the RAM, technically we need to say one process is created. The program which is started running, the program which is started executing, the program which is loaded into the RAM for execution, we can say a process. Observe this point. A process is a program in execution. A process is an instance of a program. Whatever the data present in the hard disk is technically called as a file. Will you agree? Whatever the a.out is created in a hard disk, that is technically called as a file. If this file is capable of getting executed, then it is called as a program. That file which is capable of executing, then it is called as a program. A copy of the program present in the RAM is called as a process. Observe, a copy of the program present in the RAM is called as a process. A copy of the program which is present in the RAM is called as a process. Observe, in a hard disk, if it is present, this file, it is called as a file. The same file, when it is loaded into the RAM, it is called as a process. So in a simple way, the program which is loaded into the RAM, it becomes a process. Now, can you tell me, when I double click this application, it is also one process. It started executing. When I double click this application, it is also one process. Yes or no? This is also one process. Notepad. Will you agree? Non-technically, can we say we are opening that application? Non-technically, can I say we are opening that application? But technically, the meaning of opening that application means that executable file we are loading into the RAM for execution. Again, non-technically, we are saying that opening that application. Technically, can I say when you double click that application, can I say image of that application is loaded into the RAM for execution? Can I say it becomes one? Can I say it becomes one? A process? Listen, again, my same question is, deleted and moved here, or one copy, one image is loaded? One answer is one image is loaded. Can I say the executable file which is present in the hard disk is called as a file? The same executable file, when it is loaded into the RAM, I should not call as a file, I need to call as a process. Can I say this is an active? Active? Active means it is started executing. This is a passive, it's not executing. This a.out file is a passive, and this file, when it is loaded, can I say it is an active? I hope this is clear. A program is a passive entity. A program is a passive entity, such as a file containing a list of instructions stored in the hard disk. A process is an active entity. Again, a program is a passive entity, which is a file which is having a list of instructions, and whereas a process is an active entity. A program becomes a process when the executable file is loaded into the RAM. Observe the second point. A program becomes a process. A program becomes a process when the executable file is loaded into the memory. A program becomes a process when the executable file is loaded into the memory. Now, one thing, size of an executable file is less when it is in the hard disk, and same executable file is loaded into the RAM, its process is created. Now observe what is the meaning of this. Try to understand what is the meaning of this. When we create an executable file, I don't know you remembered or not. When we create an executable file, that executable file contains two memory sections. Again, when we create an executable file, that executable file contains the two memory sections. One is the data section and another one is the code section. This executable file is present in the hard. Will you agree this? That executable file contains the data section and code section. When this executable file is loaded into the RAM for execution, apart from the, for your executable file, apart from the code section and data section, will you agree? Will you agree? Stack and heap is also added. Can you imagine now the executable file size and process size is different? Can you imagine? Can you say that executable file size and the process size is different? Hmm? And what about the life? What is the life of this executable file? What is the life of this executable file? Until and unless you don't delete it, can I say it is present in the hard disk? Until and unless you don't delete it, can I say it is present in the hard disk? But what is the life of a process? Try to imagine what is the life of a process. Can I say, will you agree? All the instructions are present in a code section. Will you agree? All the instructions are present in the code section. When all those instructions are completed, can I say life is going to end? This life is going to end. When you close this application, can I say life of that process is going to end? So try to understand the size of an executable file and the size of the process is different. The size of an executable file and the size of the process is different. And the size of the what you call life of an executable file and life of the process is different. One of your friend asked one question, sir, the process size is depends upon the OS. Now you know the stack section is 8 MB fixed. Heap section is not fixed. Data section, code section depends upon your code. Try to understand. I don't know the idea of the student who asked just 5 minutes before. Is the size of the process, is it depends upon the OS? What I need to tell you that the size of this process, stack section 8 MB, there is no doubt about it. From the day one onwards, I'm saying. Heap section, it is not fixed. You can increase, you can decrease it dynamically. Data section, code section size depends upon your code. Suppose you written 1000 instructions, code section size will be more. Suppose you written 100 instructions, code section size will be less. But OS allocates some limit. For everything, there is a limit will be there, N2. For everything, there is a limit will be there. It will take some time to understand that resource limits. When I started with the discussion of resource limits, I'll discuss that. For the time being, there is no limit. That 8 MB is fixed, and that also you can change also. Stack section size later, if you want, you can change. Further separate procedure will be there. I hope you are able to differentiate between the a.out file, a.out process. I hope you are able to differentiate between the a.out file and a.out process. Huh? So observe the life of the file in hard disk is a permanent, while life of a process is till it completes its execution. Whereas life of a process till it completes its execution. I hope these points are clear. Next example, of very simple example. To create an executable file, we'll write this ccp1.c. Suppose this is a p1.c. Then the compiler creates an a.out file. Now this executable file is present in the hard disk. To create a process, a.out, we need /a.out. So when I write /a.out, we need to press an enter button. When we press an enter button, can I say it becomes a process? Can I say it becomes a process? Now observe, I'll write this. I'm creating one separate directory, mkdir process management, cd process management, vi hello.c, stdio.h, void main, printf. Now can anybody tell me uh, now which process is running? I'm writing some code, right? There should be somebody is taking over my writing things. Which process is running? Answer is vi editor. Correct. Now vi editor is running, right? Answer is vi editor. Now observe, I'll show you. Let's open another terminal. Now observe ps-e. All of you are observing vi is running here. All of you are observing vi is running here in a terminal one. What is this ps command? What is that -e? Later one by one we'll discuss it. All of you are observing vi editor is running now. Is present there. Huh? Now I'll come out. Now can you tell me, is the vi editor is running or not? Now can anybody tell me now vi editor running or not? Observe, once again I'll type it. See, there is no vi editor. There is no vi editor here. Is this is clear? Huh? Now here there is one somebody is running here. Somebody is waiting for our input. Normally what we'll say? Somebody is waiting for input. What we'll say? Command prompt, right? But actually it is a bash. But actually it is called as a bash. What is the bash and all other things? Anyway, in a tomorrow's lecture we need to discuss it. Now observe, bash is a shell. Yes, correct. What is the shell and all other things? What is the need of a shell? Shell is an application or shell is a service. Everything we need to discuss one by one. Now let's observe. Let's compile the program. Now can anybody tell me, when I use cc hello.c, which process starts running? Now can anybody tell me, when I write cc which process starts running? Compiler, yes, cc. Now when I write /a.out, will agree? Hello. How to terminate this? Can you tell me how to terminate this? Because it is in a while one semicolon, how to control C. Now what I'll do is, yes, control C. Now what I'll do is, I'll use one function for the time being. I'm not going to discuss about that function in detail anyway. We need to discuss it later. Get PID. I'm using one function called get PID, process ID. Some header file declaration. Leave it about it. What is the process ID you got? What is the process ID you got? 128. Correct. From another terminal, let's see. When I type ps hyphen e, all of you are observing there is a dot out process 128, and from the last 13 seconds now the seconds increase. From the last 21 seconds it is running. From the last 21 seconds it is running, because while one semicolon I written. From the last 35 seconds. Now tell me, if I press Control C, if I press a Control C, now what observe is that a dot out process will be there. Now tell me, is that a dot out process is there in the process list? Will agree there is no. Now here what I am using is, I am using one function called get PID. What is that get PID, and all other things we'll see. What is the use of ps hyphen e also we need to see. Now what happens is, ps when it, what is the use of ls? Can you tell me what is the use of ls? List of files. Similarly, what is the use of ps? What is the use of ps? List of processes which are running in a current terminal. Again, list of processes which are running in a current terminal. Will you agree I opened two terminals here? I opened two terminals. Now, one small difference I need to tell you. Will you agree I am using Ubuntu as a subsystem here. Ubuntu as a subsystem here in the Windows. Huh? So what happens in this case is, here also one init will be there, here also one init will be there. Observe, when I type ps here, when I type ps hyphen e here, just a minute, ps hyphen e here, will you agree? There is a multiple init processes. Don't worry about multiple. Here one more init is also there. Don't worry about it. So when you type ps, it will display only the list of processes in this. When you type ps-e, total system, total Ubuntu, how many subsystems are running in that Ubuntu, what are the processes are running, it will display. Getting the point? All this information is there here. All this information is there. Some commands are there. I'll share you the material. In that material, see, ps display the list of processes, ps-e display the list of processes in a system, ps-l long list, fg size. There are so many things are there. And anyway, I'll share this process management related ppt pdf material today in a Moodle. So what I'm going to do is, so I'm going to share this PPT as well as I'm going to share that process management theory, process management program. There are two files are there. I'm going to share it. So tomorrow we need to discuss many more things about the process: hardware multiprocessing, software multiprocessing. What is the process manager job? What is the job of what is the use of multiprocessing? And so many things, background process, foreground process, like this we need to discuss it. Getting the point? Okay, thank you very much. Today I'll wind up this session. Tomorrow we'll discuss about many more things. This process management, it will take more time, because as I told you, if you're able to understand the process and process management, remaining portions easily you can understand. Is it clear? How to create a process: parent process, child process, orphan process, zombie process. There are so many things, are states of a process. wait state, suspend state, delayed state, PCB, context switching. There are so many words, so many things, scheduling policies, so many things are there. One by one, slowly, in a systematic way, we'll try to understand that. Is it clear? Yes, this PDF and PPT, I'll upload it. Thank you very much for attending it. So some of the students are asking when they are allowed to start interviews after the C++ completes. Once the C++ is done, you're eligible for the placements. Is it clear? Any offline update? There is no update. Okay, then I'm going to stop.